Hey guys, we're going to be real brief today on um, this last section on Earth history, and we're going to concentrate on Earth history related to North Carolina. Excuse me. We're going to go through 4 stages: Precambrian, Paleozoic, Mesozoic, and Cenozoic. Just know that we're going through those 4 sections. Those 4 sections as written will not be on anything that I'm teaching as far as exam or whatnot. But you do need to know the geological time. So the Earth is over 4.6 billion years old. Okay, so when you see BYA, that's billion years old, and when you see MYA, that's going to be million years old. Okay? So 4.6 billion years old. These are the approximate stages. Okay, in the beginning it was considered Precambrian, and as we go down it's Cenozoic. And there's a little different look at it. Okay, now let's start a little bit about North Carolina. So approximately 1.7 billion years ago, present-day North Carolina was formed. So what we call North Carolina was formed a very long time ago. 1.3 billion years ago, the first mountains of North Carolina were formed. So that's almost 5 million. The difference there, about 5 million years later, is what we have. Now, we had the Greenville Mountains. And the Greenville Mountains no longer exist, and they no longer exist due to erosion. And remember, erosion is when you carry sediment from one place to another place. Okay? And the oldest rocks of North Carolina form presently exposed in the Appalachian Mountains. Okay? Put that down in a note. Oldest rocks of North Carolina formed around this time and presently exposed in the Appalachian Mountains. As we continue on, and again, make sure you have those in your notes. Okay. We also see that around 620 million years ago, North Carolina was pulled apart by those tectonic plates. Okay, when we're talking about the pull apart, there's a strong possibility that we are talking about the divergent plates. But if we look, check this out, North Carolina, right here. Okay, this we see as a convergent plate boundary. We know it's a convergent plate boundary because 1, okay, they're coming together, and 2, there is a trench formed here. Okay, and those trenches are formed at at convergent plate boundaries. So along the border of North Carolina and Virginia, there's evidence that volcanic island arcs existed. Think about that. On the border of North Carolina and Virginia, you have volcanic island arcs like you would in Hawaii. It's pretty awesome. Now, as we move toward the Paleozoic time, Paleozoic era, we start to see that about 540 million years ago, North America and Europe, Africa moved toward each other. Okay, and the Europe, Africa plate, where'd it go? Gotta find that for a second. Oh, there we go. Okay. So when that plate came together, we started to see the formation of Kings Mountain. Yes, there was another supercontinent, but we're going to concentrate on the fact of these plates, and that is going to be our focus. And here we go again. So we looked at the fact that Virginia, the border of Virginia and North Carolina had volcanic island arcs, and now we see, okay, we're starting to see the same thing of volcanic mountains that are going to be forming now in present-day North Carolina. Oops, I missed that. There we go. So around this time, millions of years ago, the coastline of present-day Appalachian Mountains collided with one of the oceanic plates, and that's what was giving us the volcanic mountains. Moving. There we go. So here there was a collision with the plate, and now here we go back to creating volcanic mountains. Okay, it says a continent called Abylonia collided with present-day North America, and this continued the formation of those Appalachian Mountains. Okay? Appalachian Mountains are the mountains you would see typically in Asheville. It runs through, I think, 2 or 3 states. Okay, the Appalachian Mountain Range, that tells you how long of a mountain range it must be to run through that many states. So not only did the collision between the plates create or continue the formation of mountains, it also helped with the formation of Pangaea, which is our definite supercontinent. All right, so for 359 million years ago, it says decay organic matter from the trees led to coal that is currently mined today. So then those areas of North Carolina, which are still closer to the Virginia area, those borders, is where we start mining for coal. Remember that coal is a excuse me. Coal is a what happened? There we go, guys. Coal is a fossil fuel. So what happens, and we'll talk more about fossil fuels, is basically prehistoric animals died, and their decay and their self-destruction, not self-destruction, sorry about that, and their destruction, their deaths, led to the location of fossil fuels. All right, it tells us about 325 million years ago, Africa collided with North America. Okay, so here we have the continent of Africa. Here we have North America. This is where we're saying around this time, according to evidence, there started to be the formation of Pangaea. Okay, it really does fit together like a puzzle piece. How cool is that? Alright, so here we go with our Appalachian Mountains about 250 years ago. Remember our erosion. It says Appalachian erosion. Wind and rain caused the sediment was carried to lower lying land or sea. Okay, so sediment, that breaking down, weathered. Okay, that weathering process eventually led to the erosion process. It says now Pangaea was breaking up and North Carolina was near the equator. Can you imagine? It says we had tropical climate like Hawaii. Okay, some of those nicer, warmer areas. So at some point, thanks to Pangaea, we were closer to the equator. Also notice here when it talks about erosion, it said about over 320 million years ago, this is the height of the Appalachian Mountains. And due to the weathering and erosion that occurred, right now, this is this erosion has caused it to lose height. Okay, so it was here 320 million years ago at a highest point of 36,000 feet, and then there is a drop. Okay, here we have going back again. Pangaea is starting to separate, and the Atlantic Ocean is formed. Around that time, notice those other components we have there. Whoops, sorry, got a little tiny bit excited. Okay. The coastal plains were underwater, but sea level began to drop. So just think about our coastal plain area and what we mean for us as those outside portions of North Carolina, the entire coastal area. So at one point it says, hey, it was below sea level. Now we move to the Cenozoic era, and I'm going to skip some of this. Please make sure you read over it. Okay. So here's something we need to know. 5 million years ago, the Blue Ridge and Piedmont were as they were today. Did not change. Now the coastal plains were flooded again by flood waters receding. And I want to say I think it was Hurricane Floyd, for example, that gave recently the coastal plain so much water. Okay. All right. Please note this especially. The fall line is a sharp drop off in elevation, and it's located near Fayetteville. So here we have North Carolina is in the three parts: mountains, Piedmont, coastal region. Okay. The coastal is a very large chunk. So the fall line, that drop in height, is actually caused by the fall line in between the Piedmont and the coastal plain. Okay, flipping through, and I think we're actually complete. Thanks for hanging in there. Get your questions answered.